Good day, everybody. In today's video lecture, we are going to talk about the exponential function. Of course, the derivative of it. And I'm going to introduce to you only two rules that we are going to use for differentiating a given function. So here it is. Those two rule is when we have the given e raised to u or e raised to any exponent, the derivative for finding out that will be e raised to u du, and du pertaining to the derivative of the u. And on this second rule, when we have a constant or our base is constant that is represented by a, variable a raised to u is any exponent, the derivative for that will be a raised to u ln a du. And again, du represents the derivative of our u. So let's just apply those derivatives in this function. So in the first example, I have here e raised to 5x. So meaning our u is 5x. We're going to get the du. How to get that? We're going to get the derivative of 5x. And the derivative of 5x is 5. And let us apply it to our rule, which is e raised to u du. And we're going to get e raised to 5x times 5. 5 is our du. And we're just going to organize this. And this a constant 5, we're going to write it at the first or at the beginning before our e. So our final answer will become 5e raised to 5x. Let us now move forward to our second example. And again, we're going to use this rule, e raised to u du. And then I have here the given, find the derivative of the function e raised to sine x plus x to the fourth power. Oh, it's so simply because our u will be the sine x plus x to the fourth power. And we're just going to get the derivative of this. And you already know from the derivative of a trigonometric function, sine x, derivative for that is cosine x. And using the power rule for x to the fourth power, the derivative for that is 4x raised to 3 or cube. And or just use again the rule, e raised to u du is equals to e raised to, our u is sine x plus x to the fourth power times cosine x plus 4x to the 3 or cube, 4x cube. So, and then let us move forward to the next function. We're going to use this rule, a raised to u ln a du, because we have here two functions, as you can see. And on this function, we have a constant 2. And as well as this, we have variable x. So when we have our a, which is a constant or a variable, we're going to use this rule, a raised to u ln a du. But if our base is e, so you're going to use e raised to u du. So let us start. Since we have 2 or the product of a function here, we can represent this as the first term will be the u and our second term will be the 2x. And so meaning first for our u is the x cubed plus 1. And what will be the derivative for x cubed plus 1? It will be 3x squared. Eliminated na yung 1 because it's constant. So when you're getting the derivative of a constant, it is always 0. And let's move forward to our v. V is 2 raised to x. And from this, you can infer that our u is x, or our exponent here is x. So meaning, for getting the derivative of ax, since we have a variable x, it will be always equals to 1. So our du here is 1. And again, our a is equals to 2. So we're going to convert it to the format or our rule, a raised to u ln a du. So again, our a is equals to 2, so we have 2 raised to x, our u is x, and then ln a or ln 2 times 1 because our du is equals to 1. And we're going to apply right now, since I mentioned we have product of a function, of course we need to get to have the first term times the derivative of the second term plus the derivative of the first term times the second term. So we have this u dv plus v du. And our u will be this x cubed plus 1. Then multiply by our dv, which is this 2x ln of 2 times 1, of course 2. And then plus v, v will be this 2x times our du will be this 3x squared. And then from this part, as you can see, we have this common factor of 2 raised to the x power. So we can just move it out from the equation. We have 2 raised to the x, since as I mentioned, 2 raised to the x is our common factor, and then we're going to multiply it to the quantity x cubed plus 1 ln of 2 plus 3x squared. So this will be our final answer. Let us move forward now to the fourth example. We're going to use again the e raised to u du. Our function will be e raised to the square root of x plus 1. So we have already a radical sign on this part. So again, our u will be the exponent that we have. So our exponent is the square root of x plus 1. And from the rule of finding the derivative of a function given a radical, the derivative for finding it, we have square root of u is equals to du over 2 square root of u. Just always remember this format. When you are getting the derivative of any square root of something, square root of a function, square root of a constant, square root of a variable, or anything, the format will be always du over 2 square root of u. And then we're going to get the u first. So our u will be the x plus 1. The term inside our square root sign or the radical sign. And then our du or the derivative of x plus 1 is 1. And then apply or substitute this our get value or the value that we have right now into our format for the derivative of any radical. When we have the radical or square root of something, square root of u, apply it to the du over 2 times square root of u. So again, our du is 1 and our u is x plus 1. So just substitute it to this part. So we're gonna get du is equals to 1 over 2 square root of x plus 1. And we're gonna go back to this rule for finding the derivative of an exponential function. We have e raised to u du, and let's just substitute. So we have e raised to the square root of x plus 1 times this du is 1 over 2 square root of x plus 1. We're just going to multiply this numerator to the numerator. We're gonna get e to the power of square root of x plus 1, or e raised to square root of x plus 1 divided by 2 square root of x plus 1. Alright, so in this last example, we're going to use again the e raised to u du. Say we have a given e raised to quantity 2x minus 1 raised to the 4th power. So our u right here will be the quantity 2x minus 1 raised to the 4th power. And we're going to get the derivative of this. And since we have this exponent 4 here, when you're going to get the derivative, you're just going to bring it down at the front. It will be a constant 4 and then subtract 1 from the exponent 4. So we have 4 times the quantity 2x minus 1 cubed. And why we have two constant here? I mean the constant 2 here, because we also get the derivative of the inside the parentheses, like a chain rule. We use the chain rule here. And then just multiply 4 times 2, we have 8 times quantity 2x minus 1 cube. And just use this du, our value for du, substitute it to our rule for finding the derivative of a exponential function, e raised to u times du. So we have e raised to the quantity 2x minus 1 raised to the 4th power times our du is 8 times quantity 2x minus 1 cube. You can just stay still here on this part. This will be this can be our final answer. But in order for you to just organize this in a more in a specific way of putting the constant or the base of a constant to the right side before our e, so it will become 8 times the quantity 2x minus 1 cube times e raised to quantity 2x minus 1 to the 4th power. This will be our final answer. So yeah, that will be all for finding the derivative of a exponential function. Thank you.